In this video, we'll be overviewing agarose gel electrophoresis. Gel electrophoresis is a lab technique that allows you to separate DNA, RNA, or proteins by their length, and this can be used to identify a specific DNA, RNA, or protein. Agarose gel electrophoresis will utilize a block of agarose, which is a substance that's porous, so it has all of these little pores scattered all throughout it. It'll be somewhat opaque. And this agarose gel will be in a container with a positive and negative electrode. And the gel will have, on one end, it will have little indentions called wells where you can load your sample. So in this example, when we're using DNA, we would load our solution containing the DNA into one of the wells. And then we might load another well with a solution containing molecular weights that we will use to interpret the results once we're done. And as we know, DNA, which has a sugar phosphate backbone, has a negative charge. So when the electricity is turned on and these electrodes obtain negative and positive charges, the DNA, which is negatively charged, will run towards the positive electrode. And when it does this, the longer pieces of DNA will not fit through these holes very well, so they will migrate slowly. However, the short pieces of DNA will fit through the holes really well, so they will migrate quickly. So when the gel has been run, there will be different bands corresponding to different DNA lengths, where the shortest pieces of DNA will have gone the furthest because they could fit through the holes, and the longest pieces of DNA will have not traveled very far. So this allows for the separation of DNA by size, and we know that for DNA, the size is proportional to the molecular weight. What this molecular weight ladder will do is it will have pieces of DNA of different sizes and molecular weights, and when this gel is run, they will separate out just like our DNA, where the ones closest are the largest pieces, and the ones furthest are the smallest pieces. And then what we can do is we can use this to interpret our results. So let's say we're looking at this longest piece of DNA, and let's say this was a 20 kilodalton molecular weight. Well, then we know, because they ran the same length, that that's the weight of our piece of DNA, with the weight being proportional to the length. So this technique can allow for the testing of, does this solution with DNA in it contain DNA of a certain length?